Hello students, I hope you are all doing well. Let's start today's lecture which is about pair of linear equations in two variables. Okay, pair of linear equations in two variables. By considering this heading, here we have pair. What is pair? Pair is two, right? What is pair? Pair means two. Okay, and linear equations in two variables. Okay, what is this linear equations in two variables? These linear equations in two variables can be generally written as a1 x plus b1 y is equals to c1, okay, and a2 x plus b2 y is equals to c2. This is the equation 1 and this is equation 2. Okay, this each equation is a linear equation in two variables. Okay, this is a linear equation which consists of two variables, that is x and y. Okay, this is also a linear equation. This equation 2 is a linear equation which consists of two variables, that is x and y. Okay, here what is first of all, what is the linear equations? What is the linear equations? Linear equation is an equation, okay, where the highest power of the variables is 1. Should be the highest power of the variable should be 1. What is the highest power of the variable of x in equation 2? That is 1, right? 1. What is the highest power of the y in equation 2? That is also 1. So this is what the linear equation is, which consists of two variables x and y. Okay, and here they are telling pair. Pair means two. These are two pair, two linear equations in two variables, that is x and y. Okay, this is what the pair of linear equations in two variables. Okay, okay. Here this x and y are variables, okay, and here a1 a2 a b1 b2 c1 and c2 are real numbers or okay. So this is what the pair of linear equations in two variables. Let us see the types of solving methods. Okay, types of solving methods. Types of solving methods. Types of solving methods. The first one is graphical method. First one is graphical method and second one is algebraic method. Algebraic method. In this algebraic method, there are two types. That is, first one is elimination method and the second one is substitution method. Substitution method. Okay. So these are the types of solving methods. The first one is graphical method. The second one is algebraic method. In that, we are going to study the elimination method and the substitution method. Okay, without wasting your time, let's start with the first one, graphical method. Okay, graphical method. Graphical method is, what is this graphical method of solution of the linear equations into variables? Okay, it can be written as, okay, let us write graphical method of solutions of linear equation in two variables. Two variables. Okay, this is a first type of solving method, that is graphical method of solution of the linear equations in two variables. Okay, what is this graphical method of solution of linear equations in two variables? What is this? This means, let us take a graph Cartesian plane to understand it better. Okay, this is a Cartesian plane which consists of x, x, y, y dash, and x dash. Okay, y dash and x dash. Here, this graphical method of solution of linear equations in two variables involves two lines. Okay, two lines. This each line represents the equation we are took here. Okay, this is equation uh, a2x plus b2x is equals to c2. This line is of equation a1x plus b1y, this is y, is equals to c2. Okay, so this is, and here there is an intersection point here, right? This intersection point is a solution of the equations, that is x1 a1 x plus b1 y is equals to c1, this is c1, and a2 x plus b2 y is equals to c. Okay, this is a solution, can be denoted by a order pair x comma y. Okay, okay, then this is what the graphical method of solution of linear equations in two variables. Okay, let us see the steps to follow to get the solutions for these linear equations in two variables. Okay, those steps are those steps are step 1. Step 1, find two or more two or more points two or more points for each equation. For each equation, this is the first step. The second step 2 is plot the plot the line in Cartesian plane. Cartesian plane. Okay, this is the second step. The third step 3 is check check the intersection point. Check the intersection point. Okay, this is a third step. Okay, in this third step, there exist three conditions. There exist three conditions. The first one is if if the line if the lines intersect the line intersect at a point at a point the line intersect at a point, then there is there is unique solution. Then there is unique solution. Okay, when there is unique solution, when we get the unique solution, it is called as consistent system. Consistent system. Okay, consistent system. And the second case, in the case 2, if the lines are parallel, the lines are parallel, then there is no solutions. There is no solution. This is called as inconsistent system. Here I am reading system. What is system? Here we are taking two linear equations, right? So when there is when the equations are two or more, we call that as the system of equations. Okay, system of equations. And let us see the third case. If the lines are coincide, if the lines are coincides, then there is infinitely many solution. Infinitely many solution. It is called as dependent system. Dependent system. Okay, let us take an example for the better understanding. Okay, let us take an example. X plus y is equals to 4 and x minus y is equals to 2. I will take this as equation 1 and this as equation 2. The solution is, when I consider equation 1, x plus y is equals to 4. Okay, this is equation 1 and equation 2 is x minus y is equals to 2. Okay, then I will replace, I will write this equation as y is equals to 4 minus x. You can write you can write like this also. Okay, to find the value of y. Okay, then in the equation 2 I will write y is equals to x plus 2. Not x plus 2, this is 2 minus x, right? Then I will take minus common in RHS. When I take minus common, it will become minus 2 plus x, right? Then this minus will cancels. Then we get y is equals to x minus 2. So I will take this as equation 3 and this as equation 4. Okay. Now let us find the points for equation 3 and 4. Okay, let us find the points. Okay, this is x, y, x, y. When I take the value x as 1, x is equals to 0 in equation 3, I get y is equals to, when I take x is equals to 0 in equation 3, then what is y? Y is equals to 4, right? This x will become 0. When this x is 0, we get y is equals to 4. And then when I take x is equals to 1, take the value x is equals to 1, then I will get the value y is equals to 4 minus 1 is 3. I will get 3. And when I take x is equals to 2, x is equals to 2, what is the y value? 4 minus 2 is 2. So y is 2. When I take x is equals to 3, x is equals to 3, then the y value is 4 minus 3 is 1. And when I take x is equals to 4, then y value is 0, right? Y value is 0. 4 minus 4 is 0. Okay. Now let's come to the equation 4. Okay. When I substitute x is equals to 0, when I take x is equals to 0, then what is the y value? 0 minus 1 is 0 minus 2 is, when I take x is equals to 0, 0 minus 2 is minus 2, right? When I take x value as 1, then what is y value? Y value is 1 minus 2 is minus 1, right? Then when I take x is equals to 2, x is equals to 2, then what is the y value? Y value is 2 minus 2 is 0, right? Then when I take x is equals to 3, I get the y value is 3 minus 2 is 1. And when I take x is equals to 4, then the y value is 2, right? So these are the points of equation 3 and 4, or equation 1 or 2. Okay, 1 and 2. Let us draw the graph for this. Okay, I will draw it here only. Okay, I will draw that side. So we already, by the step 1, we already find the points of each equation, right? Equation 1 and equation 2, and we have to, now we have to plot the graph. Okay, plot the lines, and later we will check the intersection point. Okay, so I, okay, this is a Cartesian plane. X axis, y axis, y dash, and x dash. Okay, and these are the values: 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Okay, this is 0. Let us let us draw the points. Okay. The first point is, what is the first point? When x is equals to, for the equation 1, when x is equals to 0, y is, when x is equals to 0, y is 4. So 4. Okay. When x is 1, y is 3. When x is 1, y is 3. Let's draw the point here. Okay. But when x is 1, the y is 3. And when x is 2, y is also 2. When x is 2, y is also 2. The point will come here. Okay. Now, next, when x is 3, then y is 1. When x is 3, y is 1. Y is 1. Okay. And when x is 4, then y is 0. When x is 4, y is 0. That means the point will come here. Okay, let us draw the line for this points. It is this was the line. Okay. Now let us draw the points for equation 2 or equation 4. Okay. When x is 0, y is minus 2. When x is 0, y is minus 2. X is 0, y is minus 2. Let us draw the point here. Okay. And when x is 1, y is minus 1. When x is 1, y is minus 1. The point will come here. Okay. Now, next, when x is 2, the y is 0. When x is 2, y is 0. That is, the point will come here. Okay. Next, when x is 3, the point y is 1. When x is 3, y is 1. Will come here. Okay. Here there is here there is an intersection point right here. Okay. Then when x is 4, y is 2. When x is 4, y is 2. This will come here. Y is 2. Okay. Let us draw the line for this equation 2. So this is equation. Okay. So this line represents equation 1, that is x plus y is equals to 4, and this equation represents x minus y is equals to 2. Okay. Now we get the intersection point here, right? The third step, in the second step, we have to plot the lines in Cartesian way. That's what we did here. Okay. And the step 3, in step 3, we have to check the intersection point. We get the intersection point here, right? This is the intersection point, right? This is the intersection point. At what point we get the intersection here? What point? At this is a solution, right? This is a solution at 3, 1. At 3, 1, we get the intersection point. So we already checked the intersection point. The intersection point is 3, 1. Okay. Then this is of the form x, y, the order pair, right? So let us see at which case we get this solution. Okay. Uh, Here we get, okay. In the first case, if the line intersect at a point, then there is a unique solution. Intersect at a point. Here, uh, the two lines intersect at a point, at only one point, right? So we get the unique solution here. We get unique solution, right? 3 comma 1. This is a unique solution. So here the first case satisfies in this linear equations in two variables, pair of linear equations in two variables. Okay, for this example. So then this system of equations, system of linear equations in two variables is consistent system. Consistent system. Okay, because we get only unique solution here. Okay, unique solution. So this is what the pair of linear equations in two variables. Okay, this is what the pair of linear equations in two variables. So this ends this lecture. Thank you and take care. Bye bye. Thank you.